Good morning, my friends. We'll start APA 577, 9th chapter non-destructive examination. Non-destructive examination NDE is defined as those inspection methods which allow material to be examined without changing the or destroying the usefulness. A number of NDE methods are employed to ensure that the weld meets design specification and doesn't contain defects. So for that list of detection capabilities, the most common NDE methods. Additional methods like alternating current field measurement (ACFM) is applicable in weld inspection. They are described in this section but are less commonly used. The inspector should be aware of discontinuities common to specific base metal and weld process to assure these discontinuities are detectable. Table 6 is summary of these discontinuities, potential NDE methods, and possible solution to weld process. Common types of discontinuity. So types of discontinuity: porosity, uniform, scattered, clustered, piping, aligned, elongation. Porosity could be found in the base metal and has if the base metal is a casting. Porosity, uniformly scattered, cluster, weld metal, weld metal. Incomplete fusion, weld metal between passes. Incomplete joint penetration, base metal, weld root. Undercut, weld metal. This weld interface undercut. Underfill, weld metal. Weld interface adjacent to the weld toe and weld root in base metal, weld metal, or root face in groove weld. That is underfill. Overlap, weld interface, weld toe or root surface. Lamination, base metal general near mid thickness of section. Delamination, base metal generally near mid section of the mid thickness of section. Seam and lap, base metal surface generally aligned with rolling direction. Seam and lap, base metal surface generally aligned with rolling direction. Laminar tear, base metal near has. Crack includes hot cracks and cold cracks described in the text. Longitudinal, weld metal has and base metal, weld metal and base metal adjacent to weld. Transverse, weld metal has and base metal propagate into has and base metal. Crater, weld metal at point where arc is terminated or started. Throat, weld metal parallel to the weld axis through the throat of a fillet weld. Toe, weld metal has. Root, weld metal has. Weld interface has. Root surface or weld root. Root underbed and has. Concavity weld face, filler metal weld, that is weld metal. Convexity weld metal, weld face and fillet weld. Weld reinforcement weld metal, weld face or groove weld. So visual VT, magnetic MT, wet fluorescent WFMT, liquid penetrant PT, leak testing LT, eddy current ET, radiographic RT, ultrasonic UT. There is a typical discontinuity is present in a single windmill groove weld in a butt joint. So There are many defects, and so this is referring to this table 2. This one can match with this. Material identification, the responsibility of the owner user to establish the written material verification program indicating the extent and type of EMI to be outlined in API 578. They are doing like this. The porosity 1 to 1A, 1B, 1C, all 1D, 2A, 1D, 1, all things are there. 5, 5 or what? Let us see. 1, 2 is porosity finish. Okay, incomplete fusion 3, 4, joint penetration. This for incomplete penetration. So incomplete fusion is not welded. Your welding not happened. Welding is not perfect here. 5 is undercut, underfill. 5, 6. They're not representing very good. 5, 6, 6, 6, 6. Here underfill. Okay. Overlap lamination 7, 8, 7, 8, 9. Lamination, delamination, overlap. The 7, 8. Lamination, delamination. 7. This is 8, 9, 7. This seam and lap laminar tear. This is seam and lap and lamellar tear. Lamellar tear. Eleven. Not given 11. In 12 crack. What cracks? They put A, B, C, D like this. Longitudinal transverse crater throat to root underbed. That's what they try to show here. 12A, 12A, 12D, 12G, 12B, 12F, 12D, all this, and then concavity, convexity, weld metal reinforcement. The notes on here. Material identification. The responsibility of the owner user to establish a written material verification program indicating the extent and type of PMI to be outlined in API 578. Capability of the applicable inspection method for U-weld type joints. Butt weld, RT, UT, PT, MT, VT, VTLT, corner, RT no, UT, PT, MT, PT, LT, T joint, UT, PT, MT, VT, LT, lap joint, PT, MT, VT, LT, edge, PT, MT, VT, LT. Capability of applicable inspection methods versus discontinuity. So porosity, RT is good, PT is good, if open to surface, MT no, VT okay, open to surface, leak testing if through, slag inclusion, RT okay, UT not okay, PT okay, if open to surface, BT open to surface, incomplete fusion, UT okay, PT no, U usually not used, LT usually not used, undercut, RT okay, PT okay, VT okay, overlap, RT, PT, MT okay, cracks, UT, PT, MT, VT, ET, LT, lamination, UT, PT if it is open, MT if it is open, BT if it is open, ET usually not done, LT usually not done. Then material type of discontinuity, carbon steel, hydrogen cracking, SMW, FCW saw, BT, PT, MT after cool down, low hydrogen electrode preheat post it, clean weld joint, lake of fusion, all UT, proper heat input, proper welding technique, incomplete penetration, all RT, UT, VT, proper heat input, proper joint design, undercut, SAW, SMW, FCW, GMW, VT, reduced travel speed, slug inclusion, SMW, FCW, saw, RT, UT, proper welding technique, cleaning, avoid excessive wearing, porosity, all RT, low hydrogen, low sulfur environment, proper shielding, burn through, SAW, FCW, GMW, SMW, RT, VT, proper heat input, arc strike, all VT, MT, PT, micro etch, removed by grinding, lack of sidewall fusion, GMWS, UT, proper heat input, vertical appeal, tungsten inclusion, GTAW, RT, arc length control, austenitic stainless steel, certification, cracking, all PT, proper filler, female ferrite content, proper joint design, hot cracking, SM, SAW, CW, GMW, SAW, RT, PT, UT, low heat input, stringer bed, incomplete penetration, all RT, UT, proper heat input, undercut, SAW, SMW, FCW, GMW, VT, reduced travel speed, slag inclusion, SAW, SMW, CAW, SAW, RT, UT, proper cleaning, porosity, all RT, low hydrogen, low sulfur environment, shielding, arc strike, all BT, micro etch removed by grinding, tungsten inclusion, GTAW, RT, arc length control. Visual examination, VT. Visual examination is the most extensively used NDE method for welds. Direct visual examination is conducted when assessed sufficient to place the eye within 6 inch through 24 inch, 150 mm through 600 mm of the surface to the examine and an angle not less than 30 degree to the surface as illustrated in figure 14. Mirrors may be used to improve the angle of vision from the backside or reverse side. Remote examination may be used aids such as telescope, borescope, fiberscope, cameras, or the suitable instruments provided they have a resolution at least equivalent to that which is attained by direct visual examination. So that is direct visual examination requirements. As my section B, Article 9, list requirement of visual examination. Codes and specification may list compliance with those requirements as mandatory. Some requirements listed in this article include the following: personnel are required to demonstrate annually completion. Jagger J1, Jagger type eye vision test. Direct visual examination requires assess the permit the eye to be within 6 inch through 24 inch, 150 mm through 600 mm of the surface at an angle not less than 30 degrees. Visual inspection tool. The visual inspect and evaluate welds, adequate illumination, and good eyesight provide the basic requirement of addition. A basic set of optical aids and measuring tools specially designed for weld inspection can assist the inspector Listed below are some commonly used tools to method of BT welds. Optical aid, lighting standards such as ASME Section 5 Article 9 specify light levels of 100-foot candles, 1000 lux. Now it is 1075 lux. At the examination surface, mirrors, magnifiers, borescope and fiberscope from remote inspection. Mechanical aid, steel rules, vernier scale, combination, square set, thickness gauge, levels, weld examination, device inspector kit, figure 15, breech cam gauge, 16. So inspector kit contains some of the basic tools needed to perform adequate visual examination while during stages of welding. Lighted magnifier to vernier caliper can be used to determine well-prepared angle prior to welding. Weld preparation angle. This tool can also be used to measure excess weld when metal weld reinforcement, depth of undercut fitting, fillet weld throat size or weld length, leg length and misalignment. Fillet weld gauge, adjusted fillet weld gauge, skew teeth type weld gauge, measuring the angle of vertical member. The inspection kit figure 15. The breech cam gauge, the adjustable fillet weld gauge, the skew fillet weld gauge, the weld fillet gauge, weld size gauge, with high-low welding gauge, figure 22, digital pyrometer temperature sensitive crank. This is the weld fillet gauge, weld size gauge, this is the high-low gauge. You can see the difference, how much high-low. Magnetic particle inspection, MT, general. Magnetic particle examination is effective in locating surface or near surface discontinuities of ferromagnetic materials. It is commonly used to evaluate weld joint surface. So without ferromagnetic materials, no MT. Okay. Commonly used to evaluate weld joint surface intermediate checks of weld layers and backgouge surface of the complete welds. Typical type of discontinuities that can be detected include cracks, lamination, lapse, seams. In this process, the weld heat affected zone is locally magnetized, creating a magnetic field in the material. Ferromagnetic particles are then applied to the magnetized surface and are attract to any breaks in the magnetic field caused by discontinuities as shown in figure. So the disruption of the magnetic field caused by defect open to the surface or very near to the surface. The particles used during exam can be either by dry or wet. If the examination is performed in a normal lighting, color of the particles should provide adequate contrast with the exam surface. The best result is achieved when the lines of flux are perpendicular to the discontinuity. Typically, two inspections are performed, one parallel to the weld and another across the weld to provide maximum coverage. When a magnetic force is applied to the material, a magnetic flux field is created around and through the material discontinuities that are perpendicular to the line of flux attract the magnetic particle, causing the indication as shown in figure 26. These are 23 surface breaking discontinuity, subsurface discontinuity, the radiate sensitivity where fluorescent magnetic particle WMT technique may be used with the technique. A filtered backlight is used to observe the particles, which requires the area of testing is darkened. Magnetic flux detection indicator. The direction of magnetic flux direction can be confirmed by use of several indicators. One of the most popular indicators, pi gauge. It consists of 8 low carbon steel segments braced together to form an octagonal plate. The copper plated on one side to hide the joint lines. The plate is placed on the test specimen adjacent to the weld. During magnetization of the copper side up, the particle are applied to copper face and outline of orientation of the resultant field. Demagnetization. When a residual magnetism in the part could interfere with the subsequent processing or usage, demagnetization techniques should be used to reduce the residual magnetic field to within acceptable limit. If a residual field is left in a partially completed weld, the field may be deflect the weld arc and make it difficult to control the weld deposit. Flux lines. Detecting discontinuities parallel to the weld. Pi gauge. Alternating current field measurement SCFM. The SCFM technique is an electromagnetic non-contacting technique that is able to detect size and subsurface surface breaking defects in a range of different materials and through coatings of varying thickness. The technique can be used for inspecting complex geometries such as nozzles, ring, grooves, grind out areas if required minimal surface preparation, and can be used to elevated temperature up to 900 degrees 482 degrees centigrade. However, it is less sensitive and more prone to operator errors than WFMT. SFM is used for the evaluation and monitoring of existing cracks. During these are used to mathematical model lookup tables and eliminate the need of calibration of SCFM instrument using calibration piece. The artificial defects such as slots is not needed. PT is capable of detecting surface connecting or opening discontinuities in non-ferrous alloys. Liquid penetrant examination can be used to examine the weld joint surface. Intermediate checks individual weld passes in completed weld. PT is commonly employed on austenitic stainless steel, where magnetic particle examination is not possible. The examiner should recognize that many specifications limit contaminants in the penetrant material, which could adversely affect the weld and parametal. Most penetrant manufacturers provide material certification on the annual amount of contaminants, chlorine, sulfur, and halogen. The limitation of PT is that standard penetrant systems are limited to a maximum of 125 degrees Fahrenheit, 52 degrees centigrade, and so the weld must be Cool when significantly slow down the welding operation. High temperature penetrant system can be qualified to extend the temperature envelope. So these are fluorescent penetrant technique. Three different penetrant systems are available for use: solvent removal, water washable, post emulsifiable. Eddy current. Eddy current inspection is used to detect surface discontinuities and in some cases subsurface discontinuities in tubing pipe, wire rod and bar stock. Radiographic RT. RT is a volumetric examination method capable of examining entire specimen rather than just the surface. It is a historical approach to examine completed welds, the surface and subsurface discontinuities. The method uses just a change in absorption radiation by solid metal, and in areas of discontinuity, the radiation transmitted reacts with the film and latent image is captured, and when the film is processed, developed, creates a permanent image radiograph of the weld. Some methods are available which use electronics to create a digital image and are referred to as filmless due to the hazard of radiation and the licensing requirement. The cost is the higher and trained and certified person more limited than the other ND methods. ND examiner that performs the film interpretation, evaluation and reporting should be certified as a minimum 2 ASNT level 2 requirement. However, all personnel performing radiography are required to attend radiation safety training and comply with the applicable regulatory requirements. The exposure and processing of radiography is considered acceptable when it meets the required quality features in the terms of sensitivity and density. Standard for industrial radiography required the use of one or more image quality indicators IQI to determine the required sensitivity is achieved. IQI spectrometers are tools used in industrial radiography to establish the quality level of radiographic technique. IQI spectrometers are selected based on the following: material being radiographed, the IQI must be made from the same alloy material group or one with less radiation absorption. Thickness of the base material plus reinforcement. The thickness of the baking ring or strip is not a consideration in IQI selection. Wire type IQI magnetometers are constructed in the array of 6 parallel wires of specified diameter. They are made with substantially the same material as the component being radiographed. Wire type IQI magnetometers are placed on and perpendicular to the weld prior to the exposure of a radiograph. Diameter of the smallest wire that visible as a lighter white image on the radiograph provides an indication of the sensitivity of radiograph. Hole type IQI penetrometers are strips of metal of known thickness with the holes of specified diameter drilled or punched through the sheet. They are made of substantially the same material as the component being radiographed. The thickness of the hole type IQI penetrometer is generally specified to represent approximately 2 or 4% of the thickness of the object being radiographed. The holes in the IQI penetrometer are projected on a radiograph as darker black gray spots. The thickness of the IQI penetrometer and the diameter of the smallest hole that is visible as a darker image on the radiograph provide the indication of sensitivity of radiograph. Radiographic film. Radiographic film class 1, class 2 are acceptable to use. The film is required to be sufficient length and width to allow the minimum of 1 inch on the consecutive circumferential exposure. The 3/4 inch 19 mm coverage on either side of the weld. Pipe wall or weld thickness in mm. Essential hole diameter. So that is as per section 5 of this 0 to 0.25 essential hole wire 0.025. So 0.025 to 0.375, 0.030 is 12, 15, 17, 20, 25, 30. So from here it is 30, 35, 0.035, 0.040, 0.050. So from 20 it is coming to equivalent. It is 2 into this tau, and this is 10.375 to 5.5, 17, 0.5 to 0.75, 20, 0.75 to 1 inch, 25. So 1 inch to 2, 30. Radioactive source selection. For weld inspection, typically radioactive isotopes of iridium 192, cobalt 60 are used in X-ray machines. May also be used in iridium 192 is normally used to performing radiography of steel with thickness range of 0.25 2.3 mm, 3 inch, to 0.25 to 3 inch, 6.3 to 76.2 mm. Cobalt 60 is used for steel thickness of 1.5 inch, 7 inch, 38 mm to 178 mm. The minimum number of or maximum thickness that can be radiographed for given material is determined by demonstrating that the required sensitivity has been achieved. Film processing. Exposed film can either be hand processed or the examiner may use automatic process. Normal developing time is 5 to 8 minutes at 68 degrees Fahrenheit at 20 degrees centigrade. So there are general most effective techniques. One of the radiation process through the single thickness material being radiographed and the film is in contact with the surface opposite to the size. Single wall technique, single wall exposure technique should be used for radiography. Whenever practical in the single wall technique, the radiation passes through only one wall of the material of the weld, which is viewed for acceptance of the radiograph. Single wall viewing. For materials and the weld components, the technique may be used which radiation passes through two walls and only the weld material, the film side wall is viewed for acceptance. Adequate number of exposures should be made to demonstrate that the required coverage is met for the circumferential welds. Minimum of 3 exposures taken in 120 degrees to each other should be made. Double wall technique. So material and for welds component 3.5 inch or 88.9 or less in normal outside diameter, a technique may be used in which the radiation passes through two walls and the weld material in both walls is viewed for acceptance in acceptance on the same radiograph. The double wall viewing of the welds, the radiation beam may be offset from the plane of weld and at the angle sufficient to separate the images of the source side portions and the film side portions of the weld. So there is no overlap of the areas to be interpreted. And complete coverage is required. A minimum of 2 exposures taken at 90 degrees to each other should be made of each weld joint. Then you have to follow your company rules. Some companies 3, some companies 2 is okay. Evaluation of radiograph. That is single wall exposure. Superimposed straight offset ellipse, that is double wall offset. A weld crack is generally tight and not always detectable by radiography unless their orientation is somewhat in the same plane as the direction of radiation. Lack of fusion is typically narrow and linear, tends to be straight then crack. In many cases, lack of fusion is located at the weld bevel angle or between two subsequent weld bed passes. This may add the degree of difficulty in identifying the condition. This condition. Viewing facilities need to provide sub-view background lighting of an intensity to avoid troublesome reflections, shadows, and glare. The radiograph. Low power magnification device 1.5 to 3x may be used to aid the film interpretation evaluation, but too high the magnification also enhances the graininess of the film. Quality of radiographs. Radiographs should be free from mechanical, chemical, or other blemishes to the extent that they do not mask and are not confused with the image of any discontinuity in the area of interest. Radiograph with any blemishes in the area of interest should be discarded and the area of is radiographed again. The specific portion of the radiograph that needs to be evaluated. This provides a minimum recommended guidance for inspector reviewing radiographs. Radiographic density. Film density is quantitative measure of film blackening, a result of exposure and processing. Clear film has a zero density value. Exposed film that allows 10% of the incident light to pass through is 1 film density. A film density 2, 3, 4 allows 1%, 0.1%, 0.01% of the incident light. So it is like 10%, 1%, 0.1%, 0.01%. So transmission in the density through the radiograph image through the body of the whole IQI penetrometer or adjacent to the wire IQI penetrometer in the area of interest should be within the range of 1.8 to 4 for X-ray and 2 to 4 in the gamma ray. Adequate radiographic density is essential. Rejectable condition the weld may go unnoticed if slight density variation in the radiograph are not observed. Densitometer of step-phase comparison film is used to measure and estimate the darkness density of the film. Densitometer is an electronic instrument calibrated using step tablet, step-phase calibration film traceable to a national standard. The step-phase comparison film is a step-phase that has been calibrated by comparison to a calibrated densitometer. A specified percentage of the base density is defined in the code or specimen. Excessive base scatter. A lead letter B with the minimum dimension half inch, 12.7 mm and 1 by 16 inch, 1.5 mm thickness is a dark image of the B on lighter background is not cause for rejection in radiograph. Interpretation. The characteristic of radiation source of energy levels with respect to material being examined. The characteristic of recording media, process of recording media with respect to image quality. Product form being radiograph. The possible most probable types of discontinuity, possible variation discontinuity. Acceptance criteria that are to be applied for acceptance determination. The application where quality of the final product is important, safety and other reliability more than one qualified interpreter should evaluate and pass judgment on the radiograph. Radiographic examination records the information reported in the include, not limited to the following. Job, contract number, identification, location marker, placement, number of radiograph, exposure, geometric on sharpness. We have to find out. X-ray voltage or isotope type used, X-ray machine focal spot size, isotope physical source size, base material type, thickness, weld reinforcement thickness, source to object distance, distance from source site to object, film manufacturer and type designation, number of film, each film holder, cassette, single or double wall exposure, single wall, double wall viewing, type, IQA penetrometer and required hole type, number designation, procedure and or code reference, examination results, date of examination, name and qualification of examiners. Ultrasonic examination. UT is capable of detecting surface and subsurface discontinuities. A beam of sound is in the ultrasonic frequency range of greater than 20,000 cycle per second. travels in straight line through the metal and reflects from the interface. So this is radiographic image, incomplete lack of LOP, lack of penetration, and this is interpass slag inclusion. Porosity, this is really left. Lack of sidewall fusion, cluster porosity. This is slag, root slag, and this is burn through. Elongated slag wagon trucks and burn through. And then this is LF due to high low. And this is isosceles, means high penetration, excess penetration, excessive penetration, upset mismatch with the lack of penetration. This is LF, lack of fusion, not penetration, one side fusion. So this is UC undercut one side, and that is crack transverse. So if undercut, it will travel like same in the root path, root toe. So if it is LF, then it is a straight line. LF due to high low and LF, so it will be straight line. These are tungsten inclusion, and this is root pass aligned porosity. So straight beam techniques are used for thickness evaluation or to check the lamination and or other conditions which may prevent angle beams for interrogating the weld. Shear wave or angle beam techniques are employed for identification of discontinuities at the weld. A-scan display. So these are A-scan display. These are B-scan display. The A-scan is shown in the figure 47, the most common display type. It shows the response along the path of the sound beam for a given position of the probe. It shows the amplitude of the signal coming from discontinuity of the function of time. The x-axis right represents the time of flight and indication of the depth of discontinuity or back wall thickness. Y-axis shows the amplitude of deflection signals, echoes, and can be used to estimate the size of discontinuity compared to non-reference reflector. This is C-scan, the top view. E-scan display, the figure that we see, shows a cross-sectional view of the object and the test by scanning the probe along the one-axis. C-scan display shows the plan view of the object. Plan means top view when you look from the top. So you can see this picture. D-scan display figure 50 shows a through thickness view showing the cross section of the test object perpendicular to the scanning surface and perpendicular to the projection of the beam axis on the scanning surface. D-scan display is exactly like a B-scan display except that the view is oriented perpendicular to the B-scan view in the plane of the plate. D-scan allows quick determination of indication along the weld by presentation of the position depth from the scanning surface. Phased array S-scan display. is the D-scan display. Is the B-scan display. This is this side view and this is this side view. Time of flight diffraction TOFD, BD scan images provide defect sizing information for through wall extent by using diffracted signals rather than pulse and echo signals. This is TOFD. So if there is a problem here, somewhere here, this is initial and final pulse, that is no problem. And this is second pulse. But there is something here, here, and on the top there is something missing here. Which is not good. You have the D-scan display. Still it is not good because can be slight filtered. This is the quick crop tip. This is the initial direct pulse, and this is the final, the backwall echo, and this is crack tip. If anything coming between, that is crack tip. And this is initial pulse. This is second pulse. This third pulse, third backwall echo. This is first backwall. Sorry, that is first backwall echo. This second backwall echo. Requirement of ultrasonic inspection. Article 4 requires a written procedure to be followed, and some of the requirements to be included in the procedure are weld base metal types, configuration examine, technique, couplant type, ultrasonic instrument type. Can we stop here? Because I think this is too much. We have to divide into part. So we stop here so that we divide 9 into 2 parts.